Assalamualaikum warahmatullahi wabarakatuh and good day class. So we still in chapter 4, Introduction to Organic Chemistry. So we have done 4.1 and 4.2. So today we want to look about 4.3 isomerism. But then we just focus on learning outcome A and B only, alright? So, take a look the learning outcomes for this lesson, for today's lesson. At the end of the lesson, you should be able to define isomerism, constitutional isomerism, and stereoisomerism. And B, identify and construct constitutional isomers. We have chain isomers, positional isomers, and functional group isomers. So what is isomerism? Isomerism is the existence of different compounds with the same molecular formula. Or compounds with same molecular formula but different arrangement of atom. So we have two types of isomer. Number one, constitutional isomer or structural isomer. So what is constitutional isomerism? Compounds with same molecular formula but different structural formula. Same molecular formula, different structural formula. So we have three types of structural isomer. Sekejap lagi kita tengok. And then number two, stereoisomers. Compounds with same structural formula but different special arrangement of atoms. Alright. So hari ini kita tengok constitutional isomer first. So this is summary about both of the isomers. Constitutional isomers differ in connectivity of atoms. So we have chain isomer, positional isomer, and the last one is functional group isomer. For stereoisomer, differ in 3D arrangement. So we have two types of stereoisomer, cis-trans isomer and optical isomer. Cis-trans isomer dikenali juga sebagai diastromers and optical isomers is enantiomer. For diastromer, it is non-mirror image and for optical isomer, it is mirror image. Okay, kita akan lebih spesifik nanti the next video. Alright. Seperti yang Madam cakap tadi, okay, constitutional isomer can be divided into three different categories. Chain isomer differs in structure of carbon chain. Okay, so nama pun chain, dia akan differ in the structure of carbon longest chain. Okay, and then the positional isomer differs in the position of functional group. Okay, positional, that means differs in the position of functional group. Okay, kita dah kenal functional group. And then for functional group isomer, same molecular formula but different functional group. Okay, for functional group isomer kita kena ingat ada 4 group yang berbeza. Kita kena ingat dia punya pasangan dia, partner dia. Alright. So kita tengok yang pertama dahulu, chain isomerism or skeletal isomerism. So chain isomers, alright, same molecular formula but different functional group. Alright. So, for chain isomerism, differs in the structure of their carbon chain. Right? Different physical properties and similar chemical properties. Chemical properties adalah dia punya reaction dia. Okay, chemical reaction. Physical ni adalah boiling point, okay, solubility. Alright. For example, we have C5H12. Okay, so you have 5 carbon. Okay, we have 5 carbon. So, first kali kita akan buat 5 carbon in longest chain, straight and longest chain, 5 carbon. And then we reduce, okay, reduce the carbon to 4 carbon. Okay, and then kita akan letak satu carbon di carbon nombor 2. Let's say this is carbon number 1. Okay, this is carbon number 2. Okay, this is carbon number 3, number 4. So the longest chain here adalah 4 carbon, this is 5 carbon. So dia dah jadi chain isomer between structure number 1, let's say this is number 1, and structure number 2, this is chain isomer. And then kalau kita letak CH3 yang ini, kita letak pada carbon number 3, it's still the same. Okay, kita akan count from the right side. So kita akan numbering the longest chain, okay, from the side that have the substituent have the lowest possible number. For this one, okay, CH3 at carbon number 2. So if we put here CH3, okay, if you put here CH3 here, so number 1 we will start from the right side, 1 2. Okay, sebab the CH3 must be the lowest possible number. Alright, so it is still the same. So kita akan letak CH3 at the same carbon like this. So we have longest chain is 3 carbon, 1 2 3 carbon, and then at the same carbon number 2 we have CH3. So kita dah ubah dia punya longest chain, maksudnya the relationship between all the structures are chain isomerism. Okay, and another example, C6H14. So we have 6 carbon. So the longest chain is 6 carbon. So kita akan susun 6 carbon dahulu, and then kita akan lengkapkanlah semua dia punya H. Ini madam buat rangka dia saja kan, tapi kena betul kena lengkapkan H dia lah. And then longest chain madam ubah kepada 5 carbon, and then put the carbon CH3 at carbon number 2. And then still 5 carbon, madam put the carbon, okay, the CH3 here at carbon number 3. Alright, so if we put the carbon here, the CH3 here at carbon number 4, is still the same with this structure. Right, and then for the longest chain, for carbon, okay, we draw for carbon, and then kita akan letak pada carbon number 2 and carbon number 3. And then kita ubah the CH3 at the same carbon. Okay, let's say this is carbon number 1, carbon number 2, 3, 4. Okay, kita akan letak pada carbon yang sama, number 2. Kalau kita letak dua-dua carbon ni pada carbon number 3, dia still sama juga. Okay, sama. Kalau kita belajar dia punya naming, nama dia sama. Sebab kita akan kira the longest chain here, longest and continuous chain here as a parent chain. Okay, kita akan nomborkan mengikut substituent ataupun branch yang supaya dia dapat the lowest possible number. Okay, and then example 2, another example, C6H14 tadi. Okay, ini madam tulis balik lah. Okay, nama dia tadi. Okay, so nama, kalau nama sama, maksudnya dia adalah benda yang sama. Walaupun struktur dia kita nampak berbeza kan, tapi kita ada rule nak namakan dia. Okay, and then this one adalah 3-methyl. Okay, so 2-methyl here. So kita akan nomborkan 1, 2 here lah. Okay, sebab tu namanya 2-methyl, because methyl group at carbon number 2. So 2-methyl pentane because the longest chain is 5 carbon, and then methyl group here at carbon number 3. Okay, kalau kita nomborkan start from the left or start from the right, is this the same. Okay, so it become a 3-methyl pentane. And then kita letak 4 carbon as the longest chain. Okay, the CH3 group at carbon number 2 and 3, so it become 2,3-dimethyl butane. Okay, and then if we put the CH3 group at the same carbon, okay, here is carbon number 2, so it become 2,2-dimethyl butane. Okay, so total we have how many? We have 5 constitutional isomers. Okay, so if you have C5H12, Okay, for example, we have C5H12. Kita cuba lukis macam mana yang dia katakan tadi, macam mana dikatakan sama. Okay, let's say dia letak kat sini 4 carbon, CH3 add carbon here. And then another one dia letak dekat atas. Okay, still add carbon yang sama, number 2. And then CH3 dia letak from the right, okay, it become carbon number 2. Okay, so dia letak kat sini. And then dia letak CH3 dekat atas, at the same carbon here. And then bila buat macam ni pula, okay, nampak macam berbeza dengan yang lain, but then actually dia adalah yang sama sebab kita akan kira the longest chain adalah bukan straight sahaja kita kira, kita akan cari the longest and continuous. Okay, maksudnya paling panjang dan continuous. Okay, kalau kita tengok, dia boleh pergi ke atas, dia boleh ke bawah tanpa mengangkat pen ni. Okay, this is the longest and continuous. It is 4 carbon. And then kalau kita nomborkan, it is carbon number 1 here, and then this is carbon number 2. So CH3 at carbon number 2, okay, it is still it is same with this structure number 2, and then here number 2. Okay, so that's mean semua ni, okay, all the structures are actually 2-methyl butane, sama. Okay, so just take note sajalah. Okay, so you must be able to recognize when two different looking structure are actually the same molecule written in different ways. Okay, tapi dia adalah structure yang sama because the name is the same. Alright. And then we have C8H10. Okay, C8H10 dia ada benzene ring. Okay, sebab apa? Kalau kita nampak carbon, okay, dan hydrogen dia hampir-hampir sama, okay, maksudnya dia ada benzene ring. Okay, tapi nanti kalau kamu dah biasa dengan organik, kamu tahulah. Okay, so the first structure is 1,2-dimethyl benzene. Okay, because the carbon here CH3 at carbon, let's say this is carbon number 1, carbon number 2. Kita akan bagi nombor pada untuk this substituent, okay, CH3 here must be lowest possible number. Okay, tak boleh nombor 1 sini. So nanti dia akan jadi 1, 2. So dia akan jadi number 2. Okay, 1, 2, 3. Dia akan jadi number 3. So kalau kita tak number 1 sini, akan jadi 1, 2, 3 or 1, 2, 3. So dia banyak nombor dia, kita tak nak. Okay, so dia mesti lowest possible number. So here is 1,3-dimethyl benzene, and then 1,4-dimethyl benzene. Okay, so it differ in the in terms of chain. Okay, kat mana yang dia position dia yang berbeza. So it is chain isomerism because the here is the same, right? And then C4H9OH, okay, it is alcohol. Okay, alcohol yang ada hydroxyl group. So kita buat dulu 4 carbon. The longest chain is 4 carbon. So 4 carbon here. Okay, this is the longest chain, 4 carbon. And then we must put number 1 here. Okay, so the functional group must have the lowest possible number. So number 1 here. And then kita tukar dia punya chain. Okay, kita tukar dia punya longest chain. So it become 3 carbon. Boleh juga buat macam ni straight ataupun boleh ke bawah. Jadi dia longest and continuous. So the OH group still at carbon number 1. Kita tak ubah the position of OH group. Sebab kalau kita tukar position of OH group, so it become the positional isomer. So kita hanya ubah dia punya chain sahaja. Okay. Alright. So ini adalah contoh last lah untuk chain isomerism. Okay. And then, okay, number 2 is positional isomerism. Okay, positional isomerism have a same skeleton. Maksudnya longest chain dia sama. Okay, same homologous series but differ in the position. Position of what? Position of functional group. Okay, same chemical properties of course, but the same functional group but different physical properties. Okay. For example, you have C3H7Cl. Okay, the longest the total carbon is 3, so the longest one kita buat yang 3 carbon dahulu. So it become 1 chloropropane, and then we change the position of Cl group here. Okay, the halogen group, okay, it become at carbon number 2. So this is carbon number 1 tadi, number 3. Okay, number 1, 2, 3. So it become 2 chloropropane. So the relationship between 1 chloropropane and 2 chloropropane is positional isomerism. Okay, and then C4H8. Okay, C4H8 adalah general formula untuk mematuhi general formula untuk alkene. Okay, so alkene is carbon-carbon double bond. Okay, first kali kita buat double bond between carbon number 1, carbon number 2. So we have 4 carbon here. Okay, and then nama dia adalah 1-butene. Okay, because the double bond at carbon number 1. Okay, yes, the carbon double bond is between carbon number 1 and carbon number 2. Tapi kita akan ambil the lowest number here is number 1. So it become 1-butane. Okay, and then another one is we change the position of double bond become at carbon number 2 between carbon number 2 and carbon number 3. Okay, so the name is, the double bond is between carbon number 2 and 3. So kita akan namakan mengikut nombor. Kita akan tulis nombor kat mana position double bond. Kita akan ambil nombor the lowest one. Okay, which is carbon number 2. So it become 2-butene. Okay, so relationship between 1-butene and 2-butene is positional isomer because it does not change the longest chain here. For carbon is still the same. The skeleton carbon is still the same. Okay, but the position of functional group are different. Alright, so the relationship of both of the structures is positional isomers. And then we have C3H8O. Okay, so this one adalah alcohol. We have 3 carbon, propanol ataupun 1 propanol ataupun propane 1-ol. And then without changing the skeleton carbon, okay, it's still carbon. We have 3 carbon. The longest one is 3 carbon, but then we change the position of OH group from at carbon number 1 to at carbon number 2. Okay, the position, okay, kita tukar. So that's mean it is a positional isomer. Okay, both isomer have the same skeleton. Okay, apa dia katakan skeleton? Ingat tak kita dah belajar skeleton structure tu kan? Kalau kita buat skeleton dalam bentuk skeleton, kita akan jadi macam ni lah. 1, 2, 3. So it become here OH. So 3 carbon here tak berubah. Macam ni juga, sama juga. But then the OH group, okay, kita ubah pada carbon number 2. Okay, so this is the skeleton, which is the carbon, okay, carbon atom, okay, tak ubah, cuma the position of OH group kita ubah. So it is positional isomerism. And then here we have C6H13N. Okay, kita ubah dia punya. So the relationship between these two structure is chain isomerism. Okay, sebab kita ubah dia punya CH3. This is also chain isomerism. Okay, and then this one, okay, yang arrow warna biru tu, okay, arrow warna biru tu kita tukar NH2 pada position yang berbeza. Kalau kita tengok dekat sini, NH2 attached at this carbon, so it become carbon number 1. So CH3 at carbon number 1. Okay, and then here NH2 kita akan nomborkan mengikut kat mana dia attached. So it is still at carbon number 1. Number 1 is here. Okay, so CH3 become number 2. And then NH2 attached this carbon, so this carbon is carbon number 1. So CH3 at carbon number 3. So that's mean the 3 structure is chain isomerism. Okay, but then the relationship between this carbon and this one, okay, adalah positional isomer. Okay, because the position of NH2, okay, is different. Dia tak attach pada ring, but then dia attach pada C. C here. Alright. So draw all isomers that have molecular formula C5H11Br. Okay, so we have in there are 8 isomers. Okay, so tadi kita ada C5H11Br. Alright. So the longest chain is 5 carbon. Kita buat longest chain dahulu, itu 5 carbon, Br attach at carbon number 1. Okay, let's say this is carbon number 1. Kalau kamu nak letak Br at okay, from the left side pun boleh juga. Okay, it doesn't matter. So namakan ni jangan risau, nanti kita akan belajar lagi spesifik. Okay, namakan ni cuma nak confirmkan balik dia tu adalah nama yang berbeza. Maksudnya dia adalah structure yang berbeza. Alright, and then bila dia ubah dia punya Br attach at carbon here. So carbon here bila dia pergi ke carbon di sini, so ini bukan lagi carbon number 4. Ini number 4 kan. Okay, tapi Br bila attach sini dia akan jadi carbon number 2. Kita akan nomborkan from the left side. Okay, so it become 2 bromo pentane. And then Br we attach at carbon number 3. Okay, so it become 3 bromo pentane. Maksudnya di sini kita tak mengubah dia punya skeleton carbon, okay, but then we change the position of the functional group. So that means semua ni adalah positional isomer. Okay, so kalau 4 carbon, okay, kalau kita tukar daripada 5 carbon to 4 carbon, okay, Br still attached at carbon number 1. Okay, kita tukar dia punya longest chain daripada 5 jadi 4. So the relationship between the first one, the previous slide, okay, yang 5 carbon, Br attached at carbon still at carbon number 1, dia adalah relationship dia adalah chain isomerism. Okay, yang panjang sekali tadi. 1, 2, 3, 4, 5 Br. Okay, here this structure and this one, okay, this structure is chain isomerism because the Br attached at the same carbon, which is carbon number 1, but then the skeleton structure, the skeleton carbon is different, okay, from 5 carbon to 4 carbon. So here is a chain isomer. Okay, and then kita buat lagi, tukar daripada carbon here to this carbon. So kita akan dapat 1 bromo to methyl butane. So 1 bromo here is carbon number 1. Okay, kita kena bagi functional group, kita kena bagi dia the lowest possible number. Okay, so lepas kita bagi lowest possible number, baru kita buat dia punya nama lah. Alright, so this is carbon number 1, number 2. So CH3 at carbon number 2, okay, Br at carbon number 1. Okay, so dia tulis 1 bromo to methyl butane. Kenapa tak tulis 2 methyl 1 bromo? Okay, sebab dia ada rule dia kalau kita nak namakan. Okay, Br kena depan sebab dia ikut alphabetical order. B dulu. Okay, nanti kita belajar naming. Okay, and then the next one is, okay, dengan skeleton yang sama di atas, tapi kita tukar the position of Br at carbon number 2. Okay, so it become 2 bromo 3 methyl butane. Okay, 2 bromo because here is carbon number 1, carbon number 2. Okay, still kita kena cari the longest and continuous carbon here. So this is the parent chain. Okay, and then number 2, number 1 mesti dari sini lah. Okay, mesti dekat hujung. Tak boleh tiba-tiba number 1 dekat sini. Okay, and then the Br group attached to this carbon. So that means kita kena numbering from the right side so that the Br group, okay, get the lowest possible number. Alright, the next one is Br attached at the same carbon, still the same carbon, carbon number 2, okay, but maksudnya kita tak ubah dia punya position of Br group, still at carbon number 2. CH3 kita tukar at carbon number 2. So between this one adalah chain isomer because the position of Br tak berubah. So dia adalah chain isomer. Okay, kalau kita tengok dekat sini, antara yang ini dengan yang ini, apa dia punya hubungan dia? Okay, kalau kita tengok hubungan dia kat sini, the position of Br juga kan. Br carbon number 1, here number 2. Okay, position dia juga. Okay, sebab dia punya skeleton sama, longest chain dia. Alright. So for 3 carbon, longest chain 3 carbon. Okay, 3 carbon here. So we put the CH3 at the same carbon, Br still at carbon number 1. Okay, so we have CH3 at the same carbon. So kamu tengok yang mana BR at carbon number 1, tapi yang berubah adalah dia punya longest chain, maksudnya dia adalah chain isomer. Senang saja ingat, kalau position of functional group berubah, that means dia adalah position isomer. Kalau chain yang berubah, dia adalah chain isomer. Tapi kalau chain tu tengok, dia punya halogen tak boleh ubah. Tak boleh, position dia tak boleh berubah. Okay. Alright, habis untuk number 2. Number 3, functional group isomerism. Functional group isomers have the same molecular formula but contain different functional groups, and therefore they belong to different homologous series. Different functional group maksudnya class of compound dia berbeza lah. Okay, dan maksudnya kalau dia berbeza, confirm lah dia punya chemical properties and physical properties pun berbeza. Okay, chemical is the reaction dia. Okay, so classes of compound that exhibit functional group isomer adalah, okay, so ini kamu kena ingat pasangan dia. Alcohol and ether, okay, alcohol and ether pasangan dia. Kenapa dia berpasangan? Sebab dia mempunyai general formula yang sama. CnH2n plus 2O. Okay, itu adalah alcohol and ether. Aldehyde and ketone, okay, general formula dia pun sama. CnH2nO. Carboxylic acid berpasangan dengan ester because they have same general formula, CnH2nO2. Okay, so kalau nampak O2 dia adalah carboxylic acid and ester. Okay, and then alkene and cycloalkane, alkene and cycloalkane is CnH2n. Okay, cycloalkane adalah, cyclo ni adalah dalam bentuk cyclic. Alkane maksudnya dia adalah single bond, carbon-carbon single bond. So ingat pasangan ni, alcohol, ether, aldehyde, ketone, carboxylic acid and ester, alkene and cycloalkane. Okay, example 1. Molecular formula C2H6O. Okay, so kalau kita tengok general formula dia apa? CnH2n plus 2O. Maksudnya dia adalah alcohol and ether. Macam mana kalau tak ingat dalam exam, madam? Kalau tak ingat, gone. Okay. So, kena tahu, right? So, we have 2 carbon. So, it becomes CH3, CH2OH. Ni adalah untuk alkohol. Okay, alkohol dia mesti ada, general dia adalah ROH. R ni adalah carbon lah. Carbon kan, alkyl group kan. Okay, so dia mesti ada OH di belakang. Okay, and then this is ethanol of course. And then kalau ether ingat lagi, ether dia mesti COC. Dia punya functional group dia adalah alkoxy. Okay. So, kita pun buat, okay, lengkapkan CH3, CH3. So, make sure the quantity of carbon and hydrogen and oxygen sama dengan molecular formula yang dibagi. Okay, so this is dimethyl ether. So the relationship between these two structure adalah functional group isomer because they have the same general formula but then it is different what class of compound, pasangan alkohol dan ether. And then kita tengok C3H6O. Okay, dia punya general formula adalah Cn, this is N. Okay, kalau kita tengok ni 2 kali ganda, so dia akan jadi CnH2nO. It is aldehyde and ketone. Aldehyde dia mesti apa? Dia mesti R C double bond O H. Ketone dia mesti R C double bond O R. R adalah alkyl group, CH3, CH2, CH3, CH2, CH2, CH3 and so on. Alright. So the aldehyde, okay, kita lengkapkan, kita buat dulu C double bond OH and then you have 3 carbon, right? So letak lagi, the rest is CH2, CH3. Okay. And then this is propanol. Okay, with aldehyde, okay, ni adalah belakang dia mesti al. Okay. And then we have ketone, okay. The H here, okay, kita ada 3 carbon kan. So H2 bila gantikan dengan carbon juga, okay. So satu lagi tu kita dah buang lah. So it becomes CH3, C double bond O, CH3. Okay, ketone tak semestinya dua-dua sama. Dia mesti mungkin ada, janji dia carbon, tak kisah. Okay, but that means the C double bond O adalah in between the carbon. Okay, between the carbon. So this is propanol. So relationship between these two structure adalah functional group isomer. And then the next one is C3H6O2. It is carboxylic acid and ester. Ingat kalau ada dua O, dia adalah carboxylic acid and ester. Okay, carboxylic acid adalah COOH, carboxyl group, C double bond OOH. We have 3 carbon, so the rest adalah, berapa lagi yang tinggal? We have 1 here, so it becomes CH2, CH3. And then the name is propanoic acid. And then for ester, okay, ester dia mesti apa? Functional group dia. Okay, ester adalah C double bond O, O, C. Okay, kalau kita padam double bond O ni, dia jadi alkoxy. Kalau dia ada double bond O, okay, alkoxy adalah apa dia? Alkoxy adalah ether. Ether. Kalau dia ada double bond O, namanya adalah carboalkoxy. Dia adalah ester. Alright. So, kita akan letak CH3 di situ sebab kita ada 3 saja kan. So, maksudnya tak ada pilihan lain. CH3, CH3 kiri kanan. Okay, methyl ethanoate. Okay, write the structural formula for the functional group isomers with molecular formula C4H8O. What is the general formula for C4H8O? 4 is N, H adalah H adalah 8 kan kat sini. So, it become 2N. Okay, 2N. So, this is N. So, CnH2nO. Okay. So, what is the pair for this general formula? It is aldehyde and ketone. Okay, so aldehyde mesti ada C double bond OH. C double bond OH. H adalah pada carbon. So, we have 1 carbon here. Okay, yang tinggal lagi adalah 3 lagi. Sebab total we have 4 carbon, right? So, it becomes CH2, CH2, CH3. Okay, so we have 4 carbon for aldehyde. That means it is butanal. And then for ketone, okay, ketone, we put C double bond O. And then at least dia ada CH3 dekat sini. Okay, tapi sebabkan kita ada 4 carbon sahaja kan. So, dia boleh jadi CH2, CH3 di sebelah kanan or pada sebelah kiri. Okay, so we have 4 carbon. Okay, it is butanon. Ada ONE, dia adalah ketone. Alright. So, determine the type of isomerism for C6H12. Okay, C6H12 like that. So, we have functional group carbon-carbon double bond. Okay, we change the position of double bond from carbon number 1 to 2 to carbon number 2, between carbon number 2 and 3. Okay, and then here between carbon number 3 and 4. Okay. So, this is a positional isomer. Okay, so kalau kita tengok kat sini, okay, disebabkan alkin ada pasangan dia dalam functional group isomer, okay, iaitu cycloalkane. We have 6 carbon, right? So, bila 6 carbon buat 6 carbon, okay, so confirm memang ada 12 hidrogen dalam ni. So, dia adalah functional group isomer. Okay, and then okay, pasangan ni pun functional group isomer, ni pun functional group isomer. It doesn't matter double bond kat mana. Okay, but then the relationship between these two structure adalah positional isomer because the position of double bond is different. And then here is also positional isomer, and from the first structure and the third one is also positional isomerism. So, before we end our class, okay, take a look the exercise, page 20. State how many isomers with the following molecular formula and identify the type of isomerism and draw the structural formula of the isomers. So, we have C5H10O2. Okay. So, what is the general formula for this structure? For this molecular formula, CnH2nO2. That means it is carboxylic acid. Okay, and the partner adalah ester. Okay, So, kita cuba buat senaraikan semua sekali. Okay, we can start from carboxylic acid or ester, mana-mana pun boleh, tak ada masalah. Kita akan buat dia punya structure, alright? Okay, for carboxylic acid, okay, for carboxylic acid, C double bond OOH mesti dekat hujung. Okay, dekat terminal hujung lah. So, kita akan buat dulu 5 carbon. The longest is 5 carbon. Okay, and then we reduce the 5 carbon, become 4 carbon, and then CH3 we put here. We then put here first. And then structure number 3 still 4 carbon, but then we letak CH3 at this carbon. Okay, carbon number 2. And then nampak ke tak kejap tengok. Okay, di sini. Okay, di carbon number here. And then dia letak kat sini pula. Okay, dia jadi carbon here. So, the COOH still at carbon number 1. Dia mesti nombor 1. Okay, and then we reduce the longest chain from 4 carbon become 3 carbon. And then the CH3 group and attach at this carbon number 2. Okay, so carbon number 2. That's mean di sini kita boleh tengok ada hubungan dia, iaitu antara carboxylic acid pun dia ada isomer, iaitu apa? Kalau kita tengok antara carbon number 1 and carbon number 2, okay, dia adalah chain isomer. Betul. So sebab daripada 5 carbon, okay, 5 carbon semua ni adalah chain isomer lah sebenarnya. Okay, sebab kita ubah dia punya chain. Kita tak ubah dia punya position of the functional group. So this is all here is chain isomer. Okay, and then what about ester? Alright, so kita cuba buat ester pula. And this one is for ester. Alright, so kalau ester, kita tengok ester dia mesti C double bond O, O, C. Okay, so first kali kita akan letak satu carbon saja di sebelah kiri dan the rest sebelah kanan. So total adalah 5 carbon, mestilah sama. Okay, and then we change the longest chain here. Okay, yang sebelah kanan yang ada 3 carbon ni kan. So kita tukar jadi dia berubah dari segi chain. Okay, tapi the position of C double bond O, O, C is still the same. Maksudnya di sini kita tak ubah the position of functional group, tapi kita ubah chain. Okay, maksudnya dia adalah chain isomer. Okay, between carbon number 5 and number 6 ni adalah chain isomer. And then number 7, okay, number 7 madam dah tak boleh ubahkan dia punya chain. So kita ubah C double bond O, O tu sebelah kanan. So di sebelah kiri ada 2 carbon pula. Okay, and then the rest adalah sebelah kanan. Okay, so yang ni kita memang tak boleh ubah dah dia punya chain. Maksudnya di sini antara 6 dan 7, okay, 5 dan 7 adalah positional isomer. Okay, and then number 8 kalau kita tengok, okay, madam ubah dia punya position C double bond O ke kanan lagi. So the at the left side, okay, on the left side, okay, kita ada 3 carbon. Okay, and then kanan kita ada 1 carbon. Okay, dia berbeza dengan nombor 5 ya, sebab nombor 5 ni CH3 di sebelah carbon double bond O, tapi kat sini CH3 adalah di sebelah O. Nampak macam sama kan, tapi dia adalah berbeza. Okay, and then kalau kita tengok kat sini dia berbeza kan, nombor 7 dengan nombor 8 position of C double bond O dah berbeza. Position maksudnya kat sini antara 7 dan 8 adalah positional isomer. Okay, and then number 9 dia nak ubah chain yang ada 3 carbon ni jadi macam ni. Okay, bila dia berubah, okay, maksudnya tanpa mengubah dia punya position yang ni, so dia akan jadi chain isomer. Okay, so antara, okay, kalau kita tengok dekat sini, kamu boleh tadi Meda dah cakap kan apa yang mana chain isomer, semua pun chain isomer. But then antara carboxylic acid dan juga ester, okay, semua ni antara 1 dengan 5, 2, 5, 3, 5, 4, 5 ataupun 2, 6, 1, 6, 2, 6 dan seterusnya. Semua ni tak kisahlah kat mana position the functional group, as long as carboxylic acid and ester, dia adalah apa? Dia adalah functional group isomer. Okay, antara semua ni dengan semua ni adalah functional group isomer. Alright, so bila kita buat ni memang banyak lah, tapi kita kena buat strategi supaya kita tak tertinggal satu pun structure. Alright, so habis untuk part 1 dalam 4.3. So, make sure buat homework, mastery practices number 4 and number 5. Cuba buat, okay, and then submit kat GC, okay. Meda akan ni lah sediakan ni tempat dan kamu boleh submit di GC. Alright, so kita akan jumpa pada next video, okay. Untuk bahagian seterusnya, we still in 4.3, belum habis lagi. Alright, so see you next. Thank you, student.